Hi, math lovers. Welcome to notes number 136, lesson 9.4, partial fraction decomposition. This is a great lesson today. I think you're going to love it. We're going to start by kicking it old school and thinking about how we added fractions. Back in the old days, if you had -1 over x minus 3 plus 2 over x minus 5, the first thing you'd have to do is get that common denominator, right? So you would end up finding the common denominator, writing it in the bottom. You would multiply the numerator by the number you needed. Over second term, you do the same thing. So I would end up, and remember when you were a little kid, you were like, oh, you just cross multiply. But really you didn't, but some people thought about it that way. So then we would go ahead and we would add all of our like terms together. So this would be, let's see, -1x plus 5 plus 2x minus 6 all over x minus 3 times x minus 5. And then I'd clean it all up, so it would be x minus 1 over x squared minus 8x plus 15. Okay, so what we always did is we started here. We started here. What these are called, let me use my pencil. These are called partial fractions. Okay? And then we would get to the point where we got this as our answer. So we always went in this direction. Well, today we're going to mix it up and we're going to start here and I'm going to look for that partial fraction decomposition. All right. So what you're going to do is you're going to think about the problem as your answer and you're going to come up with what fractions add together to give you that as your answer. All right. Don't worry. There'll be a great use for all of this. So I'm going to start with number 23 from your textbook. It says write 3 over x squared plus x minus 2 as partial fraction decompositions. All right, so as soon as I see this, I don't know about you guys, I'm thinking about this as 3 over, I'm thinking about this as a factored trinomial right away, aren't you? X plus 2, don't fight the urge, go for it. Write it that way. All right, now, if you were going to add some things together, what would be your fractions that would give you this as your common denominator? You would have x plus 2, and you would also have x minus 1, wouldn't you? Those would be your denominators. And then I'm going to use the placeholders a and b for my numerators there, okay? I know they're really not a and b, but a and b are just going to stand for my placeholders that I'm going to use, okay? All right, so let's start to think about this. All right, I've got, let's see. Well, I can kind of get it all together. I would think about this just like I did up top here. And this would be a times x minus 1 plus b times x plus 2. If I got it all together, right? X plus 2. I'm going to leave this as x minus 1. Wouldn't we just have this? Okay. So wouldn't I just really be interested in the numerator? Like, I don't really care what the denominators are going to be because they're going to kind of add themselves out. So I'm going to work with 3 is equal to a times x minus 1 plus b times x plus 2. Okay. Well, now what? We kind of need a value for x. All right. So let's let x equal 1. Let's see what we have. If I put 1 in for x, I'm going to have 3 is equal to, you're going to see why I picked 1 in just a second. Yeah, you know why. Because that's 0, I know. So 3 is equal to 3b. And then therefore, b is equal to 1. All right, so I figured out that b is 1. Well, what if I try over here? What if I try let x equal -2? What if I put -2 in? That's going to be interesting. 3 is equal to a times -2 minus 1 plus b times -2 plus 2. That's 0. And 0 times anything is 0. And therefore, a is going to be equal to -1. All right, so let's take this a, let's take this b, and we'll put this back on in. So this would be, let's see, -1 times x plus 2 plus b, which is 1 times x minus 1. And there's our answer, okay? So that's a super simple example of partial fraction decomposition. What you're doing is you're thinking about your fraction that you have. You're going to break it up into all the common denominators that you could possibly have there. So in this case, you're going to have just two possibilities. We're going to see some more possibilities come up as we go through. It'll be fun. And then figure out a value for x and to substitute back in. All right. Have fun with your problem sets.